Kia ora, this is question 3e from this year's Level 3 differentiation paper. I think this is probably the excellence question in the paper that needs the most thinking. I think it's a really, really lovely question. So I don't know if anyone is watching this who wrote the paper, but I think this is a great problem because it's like a step up from one of those Level 2 calculus ones with just a little bit more to think about in there. So let's have a look now that I've gone on and on about it. We've got a symmetrical graph. And at first glance, it just looks like a parabola one from level 2. And then you notice that it's not y equals 16x minus x squared, it's y squared equals 16x minus x squared. So if you've done any work on conic sections or you've done work for scholarship, you're probably recognizing that this is half of an ellipse. And we could play around with that at the end if I get time in the video. You don't have to know that at all. All you have to notice in here is that it's a symmetrical graph. And that can help if you're having trouble in seeing how to get started with the problem. So we've got a rectangle and it's drawn inside the curve and its vertices B and C lie on the curve. Let's just look at this slightly weird function first though, assuming that you don't spot the conic stuff. So we've got y squared is equal to 16x minus x squared. Well, obviously we've got all positive y values here. So I'm just going to give myself a little bit more space and get rid of this. Let's just get some room and see what's going on. We can write the function here because we've just got positive values. We can just write y is equal to the square root of this. And we're going to work with that when we're finding the area of the rectangle. But notice that if I go back to this version here, that we could factorize and we get 16 minus x times x. So we can see that this point is going to be 0 and this point is going to be 16. Now this rectangle is going to have this length here and we have to find that length so that the rectangle is a maximum area. But we're going to call that point A. It's going to have an x coordinate of x and it's going to have a y coordinate of 16x minus x squared. So the height of that rectangle is going to come from the y value, and the width of the rectangle is going to be this length here, which will be 16, and then it's going to be minus the x here and minus the x here. So it's 16 minus 2x. And those are the two bits that we need to put together to get the area of a rectangle. There's a slightly smarter way to do it that I thought about after I'd kind of worked through it, and it falls out the same way, and it's this. I'm just going to change pen color. We know that it's symmetric, and it's going to be symmetric around a value of 8. So if you don't like working with this gap and this gap, we know that the rectangle is going to be 2 times this area here. And so we could also set up our rectangle expression using that. So I haven't done that in this video, but that works out exactly the same very early on in the problem. Okay, so let's get on with it. And what we've got to do is find the x value. And from there, we've got to go back and find the length AD. So the area is equal to the length times the width, or the length times the height, or whatever. So it's going to be 16 minus 2x times, what did we have? Square root of 16x minus x squared. I'm going to write that with a fractional power. Now there are other ways that you could do this differentiation, but for me this was the kind of the most obvious way that I think most level 3 students will do it. All right, if you want to do it using implicit differentiation or something like that, you can do that as well. Okay, so we could work with a squared or do something weird like that, but I think I'm just going to get on with it, doing the chain rule and the product rule. So for a maximum, we want to find dA by dx is equal to 0. I'm going to do my product rule work here. So this is my first function, this is my second function. We're going to have 16 minus 2x times a half of 16x minus x squared to the negative a half. Now I need to differentiate the inside function. So we're going to have 16 minus 2x. Note that they match up, so that's kind of cool. plus the derivative of the first function, so negative 2 times 16x minus x squared to the half. Now, if that's the first time, if you're watching this video and you're doing this in 2026 and you've never seen a problem like this, probably looks quite daunting. But if you've done this lots of times before, you'll see that there's a whole lot of stuff is going to kind of fall out nicely. Now, this is where I'm going to write it in surd notation again. So we've got 16 minus 2x squared. And I've got a 2 in here. Let's just have a wee look. Yeah, I've got a 2 in there. And then I've got the square root of 16x minus x squared here. I'm going to pull this over to the right-hand side. I'm going to add that to both sides. And here we're going to have a 2 over root 16x minus x squared, right? Because I have got, that's not right. Just let me erase that. I have not got a negative power there. I've got a positive power. Okay, let's just slow down a bit. Right, so in here, this is just to the power of a half. So we've got equals 2 root 16x minus x squared. Okay, that's much better. Now, keeping on going with that, let's see what we get. Well, we've got 16 minus 2x squared is equal to 4 times 16x minus x squared, right? I'm getting that by just multiplying through by this side here. I'm going to pull out a common factor of 2 here, but it's 2 squared. So I've got 2 squared times 8 minus x squared is equal to 4 times 16x minus x squared. The 4's disappear, and that leaves me with what's starting to look like a nice little quadratic, and we're just about there. So expanding here, we get 64 minus 16x plus x squared is equal to 16x minus x squared. Bringing everything over to the left-hand side, I'm going to add x squared. We get 2x squared. Subtract 16x minus 32x plus 64 is equal to 0. Divide through by 2, and we get x squared minus 16x plus 32 equals 0. Now you can solve that with completing the square, or you can do it with the quadratic formula. If you're in my class, you know that I'm going to do completing the square. So we get x minus 8 squared minus 64 plus 32 equals 0. And finishing that off quickly, we get x is equal to 8 plus or minus the square root of 32, which is 8 plus or minus 4 root 2. Now, looking at my graph, one of those is going to be this value, and one of those is going to be this value. So we'll say x is equal to 8 minus 4 root 2. And we didn't have to check that it's a maximum, so we don't have to do a second derivative test. Going right back to the start, remember that what we need to get, just draw that graph badly again here, so there it is there. We want to find the length AD, which is this, and this is 16 minus 2x. So we're not quite done. I haven't seen the schedule. I'm guessing that that's probably merit getting down to there. If you get to there, you're highly likely to get the last bit. So length AD is equal to 16 minus 2 times 8 minus 4 root 2, which gives me 16 minus 16, so we get 8 root 2. And I wanted to just check that in GeoGebra, so I did a little GeoGebra thing. I'm not going to be able to use the stylus on that GeoGebra window because, I don't know, beyond my technical abilities, but we can have a look at it and you'll see when I move the points around that we have found a maximum, and I think the area of the rectangle is 64. Let's just go to the GeoGebra window. Here we go. So it's a bit of a mess, but there you go. So here's my little rectangle, and I'll just make the window bigger so that you can see. Let's have a look. Can I do this? Okay, I'm sure you guys have all hung up, but it's kind of cool because you can see that as I move these points, which is not, there we are, you can see the rectangle starting to move now. But what you can't see because of the screen setting is the rectangle area changing. And when I go in here, the area is down to about 33. As I move out, the area pulls out and goes up to, at its biggest, it's just biggest there at 64, and it starts going down again here. I don't know, I thought that was pretty cool. All right. Oh, I don't know where my OneNote's gone. Right, there we are. So that's that question done. You weren't asked to find the area of the rectangle. You were just asked to find length AD. So it's 8 root 2 is the exact value. You can work out what that is approximately if you want to do that on your calculator. Thanks for watching. I think I've got this one right, but it's pretty late at night, and if there's a mistake in here, please someone let me know quickly. But it looked like it made sense once I had checked it with GeoGebra. Okay, one more differentiation question to go on the excellence ones, and I'll be doing that tomorrow. Thanks for watching.